All right, let's talk about the retina. The retina is this very thin layer of tissue on the back of the eyeball. It is like a wet paper tissue stuck to the back of the eye. That's how it is attached, just by the surface tension created by the moisture. And when someone gets punched in the face or they hit the head of their dashboard in a car accident, they can detach their retina. The retina can come off. And then surgeons have a way to delicately place it back on. But if this is a boxer who gets a detached retina because of an excessive blow to the head, they're done. They can't play anymore because the odds of them, the retina being detached then increases dramatically, okay? And if it detaches again, it could damage. So it's a thin layer of tissue just sitting on the back of the eye based on surface tension of the liquid in the eye. Now this shows you what it's made up of cellularly, which is absolutely fascinating. So here are the rods and cones. You might have heard of them. Rods and cones, we'll talk about them. The cones, 4 to 6 million. Rods, 100 to 120 million. Cones, used for color vision. Rods, sensitive to dim and light. Cones, located near the fovea. Remember, the fovea is a point of central focus. Arguably, red favorable, green favorable, and blue favorable cones. And then the rods are black-white discrimination, large numbers on the periphery. So we see the dimness of the night. When you walk out of a restaurant at night and there's these orange glows outside of these street lights in the parking lot, and you actually cannot tell the color of your vehicle, that's because there's not enough light for the cones to work. There's only enough light for the rods to work. And you can tell what your car is, but it is gray. No matter how close you look at it, it is gray, right? So the rods have their purpose out on the periphery, but the cones are the detail. They're the ones who are looking for the best vision, and we see it with the most light. So let's talk about the rods and cones. Now, this is the most bizarre part of the retina. The retina, the light comes through all other sensory receptors. The energy source comes in and makes direct contact with the receptors of the sensory cell. But that is not the way it works in the retina. The light comes in. It has to go through these ganglion cells. And then it has to go through these bipolar cells. And then it has to go through the cell bodies of the photoreceptors so it can interact with the receptors over here. And then, once it interacts with the receptors, action potentials happen, which stimulate the bipolar cells and then stimulates the ganglion cells and sends the information to the cortex via the axons of the ganglion cells, which make up the optic nerve. Crazy. The only way this works is that if these guys are transparent, they're invisible, and these guys are transparent, and the bulk of these are transparent. So it's kind of an ass-backward system. You think if you want light to do its job best, you'd have these little proteins right up in front over here. But that's not the way it works. And that's why we have a blind spot. Because these axons have to go out somewhere, and they go out in this blind spot area, and we don't see as much as we can see. Please know the difference between the rods and cones.